Today we are going to determine whether a point is a solution of a system of equations. Now, the last couple days we had been dealing with parallel and perpendicular lines, and I used this symbol, this brace, around two equations, and what this represents is a system. Remember before I graphed the two equations on the same line? We'll get an opportunity to do that after we do this first set of directions. So this point, if it is a solution of the system, which means both equations here, that means it will work. We'll get, if we substitute 3 in for x, negative 1 in for y, we should get it to equal 5. But it should also equal 7 when we put it into the other equation. So let's try it. So I'm going to take the x value and the y value and substitute it into both equations. And I'll do them at the same time. So I've got 3 minus 2 times by negative 1 equals 5. So I just took the 3 and put it in for x, the negative 1 in for y. And then I'm also going to do this other one. So I'm going to put the 3 in for this x as well. So 2 times by 3 minus, and then minus negative 1 equals 7. So I put that negative 1 in for that y term here. I put this 3, which was x, in for this x here. And now I go ahead and do some of the work. Remember, you've got to follow order of operations, so I've got to bring down this 3 and then multiply these two numbers here. So this makes a positive 2, and sure enough, 3 and 2 do equal 5. So it works with this one. That's good. Let's check this one as well. Well, 2 times 3 makes 6, and anytime I see a minus negative, that makes a plus positive. So plus 1 should equal 7. Well, 7 equals 7, so that checks as well. So what this means is, yes, this point is a solution. So what a solution is where the two lines cross. This point is a point on both lines. And you'll see that a little bit more when we do the next set of problems. So in your answer box, you would just say yes. Well, let's try this next one. Same sort of thing. All we're going to do is substitute the point in for x and y. So we put the 1 in for x, so we'll rewrite this as 2 times by 1 plus, and then we put 3 in for the y. So I'll put that 3 right there, and this equals 5. So where I put the parentheses is where the x and the y were. Well, I just substituted those numbers in for those variables. So for the next one, it's going to be a negative 2 times by the x value, which again was 1, plus y, which is 3. So plus 3, and this should all equal 1. Well, we go ahead and do some of that work. Remember, order of operations says to multiply first. So we get 3 plus, oops, made a mistake there. Let me fix that. We end up with a, erase this other part. So again, this was a 1 back here. Well, try that one more time. Take 2 here. 2 times 1 doesn't make 3. I made a mistake there. It's only 2. And then I'm going to add 3, though. And that should all equal 5. So 2 plus 3, sure enough, that does equal 5. So that is a check. Doesn't mean that it's a solution yet. It means it works with the first equation, but we've got to make sure it works with both. So we'll try the next one here. Negative 2 times by 1 makes negative 2. Negative 2 plus 3, yeah, that does make 1, because we had to subtract because they're opposite in sign, more positives than negatives. So that's a check yes. And so that means, yes, that point is a solution of the system. It's a solution of this equation. It's a solution of this equation, so therefore it's a solution of our system. Well, one more to try. Again, the same sort of thing as before. We're just substituting the point, x, which is 2, in for x, negative 1 in for y. So we'll rewrite our equations here. We'll have 2 minus, and then 2 times by negative 1. So we put in this 2 here, that was x, in for this x here. And then we rewrote the minus sign, and then 2 times by y. Well, y was negative 1, so I put negative 1 here. And this all equals 4. So we try the next one. Again, 3 times by x. So it's going to be 3 times by, the x value is 2. and then bring down that plus sign, and y is -1. And this should all equal 6. So let's see if it does. So again, we follow order of operation, which says multiply first. So 2, and then -2 times by -1 makes a +2. Yes, those two numbers do add to make 4. Well, it works with this one, but it's got to work with both. So let's try it. 3 times 2, that makes 6. 6 plus -1 should equal 6. If it does, we'll say yes, but it doesn't. See, those two numbers don't equal. So that point is a solution of this number, or this equation, but not this one. So because it's not a solution of both, because of this point here is not on this line, that means no, it's not a solution of the system. That's not where the two lines end up crossing. Well, the next set of directions asks you to solve a system by graphing. So what we want is we want to figure out what this point is, like 3, -1. That's the solution of this system. So what we're going to do is we're going to graph these lines. So I find it best to just use the slope-intercept form, because that way you've got lots of points you can use. So I'm always going to solve for y on all these problems. So I'm going to start with this one here, -1, that's my y-intercept, so I'll plot that point. So go down 1 space and use the slope. Here the slope is -2, so -2 to 1. So that means I'm going to go down 2, right 1. And I'm going to do that a number of times until I run out of room. And then I'll also go the other direction, up 2, left 1 as well, because up 2 means +2, left 1 means -1. Now don't worry about drawing the line. All we're looking for is where the two lines cross. So let's go ahead and do the next one. We're going to start with that y-intercept of +5. So you go up 5 spaces, 1, 2, 3, 4, 5, put the dot. And then we use the slope. Well, the slope is 1. If you don't see a number out in front of x, it's always 1. Well, we can write the slope as a fraction. It's 1 over 1. Typically, we'd go up and to the right, but that's not getting us to the line. So that means we need to go the other way. So we're going to go down and to the left. And you see, right here is where they're going to cross, at this point. And you can see the line would continue down this direction. So it's not necessary to draw the lines. All we want is to find out where the two lines cross. And in this case, they cross at this point, which is 2 spaces to the left, so -2, and it is 3 spaces up, so +3. So the answer is an ordered pair. And the ordered pair is a solution, we call it. A solution is just a point on a line. But the neat thing about a system is there's only one point where the lines, these two lines, are going to end up crossing. And that is the only point. So we'll do the same thing on the next one. It's just a little bit different problems. Let's take a look at it. We've got a -3 for our y-intercept. So we'll start with that point, going down 3 spaces, putting a dot there, and then using the slope. Here the slope is 1 to 3. So we're going to go up 1, 3. Oops, didn't make it all the way over 3 spaces. Only went 2. Let's try that again. Up 1 over 3 spaces. Up 1 over 3 spaces. And then we also should go the other direction. Down to the left 3 spaces. Down to the left 3 spaces. Again, don't worry about drawing the lines. We just want to see where the two lines cross. So again, using this slope-intercept form gives you lots of points to be able to draw the line. But here, we're not in the slope-intercept form. So let's change it so it is. We always want to get y by itself. So now I have y by itself. Y equals -2x plus 4. Remember, 4 is the y-intercept. So you're going up 4 spaces. 1, 2, 3, 4. And then we're following the slope. This time the slope is -2. See, it's only the term in front of x, only the coefficient of x when y is by itself. So I have to move that 2 back over to the other side. So I'm going to go down and to the right. That's what the -2 tells me to do. And I get them to cross right at that point there. So if I go down again, you can see where that line would be. So again, that's what I have. That's what I'm trying to find, is that point where the two lines cross. And where is it? Well, it's 3 spaces to the right and 2 spaces down. So 3, -2. That's the solution of the system. One more problem to try here. Oops. And that is letter C of the second set of directions. Well, here, there's no number being added to x, so you can always add the number 0. So that's the y-intercept, the origin. And then we follow the slope. Well, what number can we put in front of x? 1 is that number, so 1 to 1. So we're just going up and to the right 1 space, and you just keep on doing that a bunch of times. And you also go the other direction as well, so down to the left. Once you do that a bunch of times, then we'll surely have a point somewhere along that line where the two lines will cross. Well, here, what we need to do is we need to get y by itself. So I think we've got an option here. We can do one of two things. We can either bring y back over and then bring the x over, or I could just subtract 3. But when I do that, I still have one more step. So it's a positive x minus 3 equals negative y. So I need to still get rid of that minus sign there. So the way I'll do that is I'll divide by a -1, or multiply by a -1. We'll do the same thing. Now when you do that, it's real important to be really careful here. We've got to get these signs correct. This is going to make a positive y, and this will be a negative x, and it will be a positive 3. So 3 is the y-intercept. Positive 3, because the two negatives here make a positive. So 1, 2, 3. And then I follow the slope. Well, the slope is -1. So we can rewrite that as a fraction as -1 over 1. So that tells me I'm going to go down and then to the right. Down and then to the right. Down and to the right. Oh, I'm not getting those lines to cross at all. Well, they actually do cross. It's just that they cross right in between 2 points. So you can kind of see where they'd end up crossing. It's going to end up being right in between those points, and it's going to be 1.5 spaces over, and then it's right here where we are going to end up using our point, and 1.5 spaces up. So we'll write the answer as 1.5, 1.5. So if they don't end up matching up right on a point, that's okay. We'll just leave it where it's at there. So those are the types of problems that we'll end up seeing on tonight's homework. We'll also have one more part for some other types of problems as well.